Hello and welcome to your science transition. Unfortunately, due to current restrictions, you weren't able to come and meet us in person in the school, but this is a short video just to help show you what you can expect from moving from science in year 6 to science here at City Academy in year 7. So first thing I wanted to show you was the team that we have here and the kind of faces you could expect to see around our department. So we have Mr. Walker, Mr. Gilbertson, Mr. Buckley, all teachers of science here and are likely to be teaching you in year 7. We've also got Mr. Coyne, Mr. Richnowski and myself, Mr. Curtis, here as teachers that you'll see around the department. Alongside the teaching staff, we've also got our technicians who help us with our practical work. Sometimes they come in to show demonstrations and you'll see them around setting up experiments and things like that for us. Is Dr. Barrett and Mr. Simpson there as well. So to show you a bit around our department, unfortunately again, we couldn't see it in person, so there are a few pictures here. We're down the corridor from the atrium towards the end. You can see some students' work there on the wall. And right at the end, we've got our fish tank where we keep all of our fish in the department. Looking in one of the classrooms then, they are going to look slightly different to your normal classroom and other classrooms around our school. Due to the nature of science, we do have these workbenches, and to be more safe and get tucked under, we've got those stools there as well. I'll show you a little video of the kind of thing that we do with the workbenches and why they need to be different to your normal classrooms.
So the difference between any of the classrooms you'll be used to and the ones we have here for science are the gas taps and workbenches we have around the side. These gas taps are there so that we can use experiments with these Bunsen burners, which produce a flame that we can use to heat things up. Obviously they do come with their own risks, and therefore almost all practicals we'll do in science will be wearing safety goggles to protect our eyes. So let's turn the gas on and get our flame started. Here we go. So as another safety precaution, we've got our mat underneath. This is a heat-proof mat. You'll see the fire goes out very quick when it's on the mat, and that keeps our workbenches safe. Just one quick experiment we can show you now to show how we're using the Bunsen burner. We've just turned up the heat a bit there. It's burning some magnesium. Now magnesium is particularly interesting when it burns because it releases quite a bright light. This is something we'll have a go at when you do arrive at school. But that's just one of the uses of the Bunsen burner we use here.
Good, so that shows you just briefly the uses of the gas taps and the workbenches around the room. Throughout your time here and your year in year 7, we will get to do quite a few experiments that link to the things we're doing. So just to give you a short description and overview of the things that you can expect to cover in year 7, science can be split into 3 subjects. We've got biology, chemistry and physics. In biology, we'll look at living things. So organisation is how the body is organised, our different organs and tissues around the body, and cells, the building blocks that make us up. Then also reproduction and inheritance. So reproduction, how we reproduce and produce offspring, and inheritance, looking at genetics and how things are passed from our parents down to offspring. Then chemistry, so using chemicals and looking at properties of matter. We've got particles and the periodic table and atoms. Now I appreciate some of these words are going to be completely new to you. I don't expect you to know anything yet. This is just to give you a bit of an overview of the kind of things that we'll do. Once you come over to us in September, we will be going through all these kind of things. You don't need to have any kind of prior knowledge at all. Some of you will have done science at school, others won't have done it at all yet, and that's absolutely fine. Then physics, we look at energy, how energy changes, how it's used, and then forces and space. So now that we've talked briefly about what we're going to cover in year 7, I want to show you what our lessons look like, and we'll have a bit of a lesson and then I'll give you something that you can go away and have a go at home. So all of our lessons look very similar. We've got a blue background that makes things really clear and easy to see. So this lesson looks at acids and alkalis. Again, this is likely to be new to you, but we'll talk briefly about acids and alkalis, and then I'll show you a little practical that you can have a go at home. So acids are a group of chemicals that all react in a similar way. So for example, when you add vinegar, which is a weak acid, to bicarbonate of soda, a chemical reaction happens. Some of you might have done this with a paper mache volcano, for example. If you add bicarb to vinegar, we get the gas released and produced along with some fizzing and bubbling that produces the lava that you might have seen on those demonstrations. So looking at weak acids, acids are found in household items like food, drinks, beauty and skincare products. So vinegar that we mentioned before is there on the board. That is a weak acid. We've then got the oranges and the lemons. In fact, all citrus fruits contain a weak acid, citric acid. So limes, grapefruits, etc. as well. But then even some skincare and beauty products do contain weak acids. And at home, they're safe to handle. Obviously, some of you will have been using them for a very long time. So they're safe to handle and even to taste if they are for eating, because they're known as weak acids. Obviously, even in the lab, we wouldn't handle or consume weak acids, but at home, they're completely safe to do so. Though some acids, like those we use here, or battery acids, things like that, are very dangerous, and they are too dangerous to taste or to touch. Acids come under what we call a corrosive category, which means they can dissolve or irritate things that they go onto, whether that be metals or even our skin. Alkalis are the opposite to acids. You might have heard me mention them earlier on. Acids can be neutralised, so brought back to normal by alkalis, and that produces a solution that isn't acidic and isn't alkaline, it's neutral. One example of that is water. Water isn't acidic and it isn't alkaline, it's just there in the middle. If we've got an acid, we can add alkali to it to bring it back to normal, back into the middle. And the way we could tell that is using a pH scale. A pH scale tells us how acidic or how alkaline a solution is when we use an indicator. So we measure acidic or alkaline solution by using the pH scale here. It goes from 0 all the way up to 14, with 7 being in the middle and neutral. To get the solution to change colour, we use a universal indicator. Now, you will have heard of indicators before on cars. They're used to tell you where the car is going. And in the same way, an indicator here tells us whether it is an acid or an alkali. So the liquid will change colour when we add it, and it tells us how strong the acid is or how strong the alkali is. We're going to have a go at making our own. Obviously in the lab we use our own chemicals, but we can also make them at home using things that you should or might have in your cupboards or would be easy to get. The colours are going to be slightly different. So here we've got neutral being this kind of pale blue colour, and going up to pinks for a stronger acid and up to yellows for a stronger alkali. I'm going to show you a little video on how to do it. So you can watch this back to have a go at home and test things around the house.
So we've talked briefly now about acids and alkalis and how we can tell whether something is more acidic or alkaline using the pH scale. To tell the pH of an acid or alkali, we need to use an indicator. An indicator tells us whether it's more acidic or perhaps more alkaline, and we are going to have a go at making our own. There's something for you to do at home. Unfortunately, you can't be with us in the transition week like we planned, but this is still an experiment you can do at home with things that hopefully you've got around in the cupboards and the fridge. So this that I'm putting in now is some red cabbage. I'm using a pestle and mortar. You could use a food processor or a rolling pin just to break it up and start to release some of the chemicals that we can find inside. Alongside the red cabbage,
We're also going to put in a little bit of table salt. You don't need very much at all. We'll put that in there as well. And then start to smash it up with the pestle and water. Once you've started to get some of the dye kind of chemically colours out of the red cabbage, we're going to add a little bit of water. I'm adding around 50 millilitres into my pestle and water. And we'll continue to squash that up. That's important with the pestle and mortar, if you have the chance to use one, you don't just keep hitting straight down, because we're going to splash and we could cause damage to our equipment. If you are using a food processor, this will be learned quicker. Once your mixture starts to turn this different colour, we're then going to filter it. I'm using just a cloth that we would find in the kitchen. We're going to strain our mixture through there just to take out those big lumps of cabbage that we weren't able to squash down. And we end up with our blue liquid in there like that. We can then use that liquid to test different chemicals around the house to tell whether they are more acid or more alkaline. So in here, I've dissolved a powder dishwasher tablet that we can then add our solution to, and we should see a colour change here. And that tells us it is a very alkaline solution. So you can try more things around the house, different drinks, other cleaning products, to look at the different pH. Good. You don't need to add all of your indicator like I did. I only had one thing to test, so I added all of my indicator. You only need maybe a few drops in there for it to change colour. And like I said, you can try loads of different drinks. Things that are clear are going to be much easier. Different cleaning products to have a look at the different pH and find out whether things are an acid or an alkali. Okay, so that does conclude what we are looking at today. If you do have any questions at all about science at City Academy, or if you just want to let me know how your cabbage indicator went, you can give me an email. My email's here. It's aaron.curtis@cityacademynorwich.org if you have anything that you'd like to discuss. And then we look forward to seeing you very soon. Thank you.